Hello everyone. Today let's solve the Leetcode 238, right? Product of array except self. So what the question says, given an integer array nums, this one, return an array answer such that answer of I is equal to the product of all the element of numbers except nums of I. Except self, right? The self number. The product of any prefix or suffix of numbers is guaranteed to fit in a 32-bit integer. That's fine. You must write an algorithm that runs big O of n time without using division operation. These two things. We should not make use of the division operation, as well as we must write an algorithm that runs in big O of n time. Right. So what we can do here, I'll just come to example. So in the example 1, we can see nums of 1, 2, 3, 4, right? So for first this one, we are excluding this one and we are multiplying this one. 4, 3 and 2. 4 into 3 is nothing but 12. 12 into 2, 24. We have got 24, right? For the second one, we are excluding 2 and we are multiplying 4 into 3 into 1, nothing but 12. We have got 12. For the third, this one, we are excluding 3. 4 into 2, 8. 8 into 1 is nothing but 8. Same thing goes with the 4. We are excluding 4. 3 into 2 is nothing but 6. 6 into 1 is 6. So the output is 24, 12, 8 and 6, right? For the second example, here anything that is multiplied by 0 will remain as 0 itself. So while we are excluding 0, then only then we'll get 3 into minus 3 is nothing but minus 9. Minus 9 into minus 1, minus into minus it becomes plus. 9 minus 9 into minus 1, 9. 9 into 1 is nothing but 9 here. All other numbers we have to multiply by 0, right? Anything that is multiplied by 0 is nothing but 0. We have got 0, 0, 9, 0, 0. So how can we solve this? We can make use of prefix and suffix product sum, right? Nothing but we can make use of first pass and second pass, right? Let's continue. Now, what we can do in the first pass? Initially, what I'll do, I'll just take the numbers here. Nums equals, we have been given in the example 1, 2, 3 and 4, right? So the goal of the first pass is to fill the result with product of all the elements to the left of each index. When we iterate here, right, we are going with the formula product is equal to product into num. Basically, first what we'll do, I'm just taking this result, this one to the empty array, and along with it, let's set the product. I'll just take P, this one, I'll just set this one to 1, right? Initially, I'll just take the product 1 and result I'm taking the empty array. Let me delete this one. So now I have numbers 1, 2, 3 and 4, right? So in the first iteration, when I equals 0, the product will be 1 itself. Result, we have set that one to the empty array and the product is 1, right? We'll push only 1. Result, first we'll push only 1 as the product is 1. Product into num. So basically, first we are pushing only 1. Second, the number is 1, right? The product 1 into 1 is nothing but 1. Next, the product, now the product is 1. 1 into 2, num, product into num, right? Formula. That is nothing but 1 into 2 is 2. Now we have, now the product is 2 and this one is 3 basically. 2 into 3, product into num. 2 into 3 is nothing but 6. Now finally, the product is 6 and here the number is 4, right? 6 into 4 becomes 24. We don't have memory for this one, right? We only have this one. We have to iterate from 0 to 3. We'll ignore this one for now. The resulting array will be basically now 1, 1, 2 and 6 in the first pass, right? So let me delete this one. Just give me a second. Now the number is 1, 2, 3, 4 and the resulting array is 1, 1, 2 and 6 as we know, right? Now in the first pass we have got 1, 1, 2, 6 in the resulting array, right? Now let's move to the second pass. So what we are doing in the second pass is, the goal of the second pass is to mainly multiply each element in the result, this one, each element in the result, these things, by the product of all elements to the right of each index. First, what we'll do, first step is, we'll set the product to 1. Basically, we'll reset the product to, again, 1, right? Then we'll iterate, right, from the right side. So now the formula is product result equals result into product. So basically, what is the result? This one. From the right side we are taking. First one is 6. Basically, result equals result into product means, result is 6 and the product is initially 1. This one, right? Basically, we are considering this one. We are considering this example. So initially, result equals result into product. Basically, the result we are considering from the right side. So result is 6 and the initially product is 1. 6 into 1 is nothing but 6, and we will update the product as well. For that, formula is product is equal to product into nums of j, right? Initially, the product is 1, nothing but this one, 1, and the nums of j, nothing but here, this one, 4. From the right side we are considering, the number is 4. 1 into 4 will be 4, right? Now the product is 4 and the 6. So yeah, this is, the result is nothing but 6. Result is 6, the product is 4. Next, we'll do the same thing. The formula is result equals result into product, right? So basically, we have got the result. Product. Now, the formula is result equals product, result into product, right? Now, the result is this one, 2. And product, we have got, the last product is 4. 2 into 4 is 8. Now, the result is 8. And product, the formula is product equals product into nums, right? Basically, the product is 4. Now, the product is 4 and the num is 3. This one, right? Third one. 4 into 3 will get basically 12. Now, this is 12. So, in the next iteration, j will be 1 basically. The formula is product equal, result equals result into product. This time, result is 1 and the product is 12. This one, 1 into 12 is nothing but 12. 12 is the result, and for the product, product equals product into nums. Basically, product is 4. 4, product is 12, right? Initial product is 12. 12 into this time 2. This one, 12 into 2 is nothing but 24. 24 is this one, product. So the last iteration is, what we'll do, we have got the result 6, 8, 12. The final one is product equals product into, result equals result into product, right? So basically, what we are doing, 1 into 24, right? This one, 1 into the last product is 24. 1 into 24 is nothing but 24, and this one is the result, and product is, product into nums. Basically, the product is 24. The last product, this one is 24. 24 into the final one, first one. Nothing but 24 into 1 is 24 itself. 24 is the result and 24 is the product. The result we have got here is 6, 8, 12 and 24. You can observe 6, 8, 12 and 24. Let me delete this one. Now, the result array is 6, 8, 12 and 24 from the right side, right? So, this should be 24, 12, 8 and 6. So, what output we have to get? We have to get 12, 24, 12, 8 and 6. We have got the same output. This is correct, right? Same goes with the example 2 as well. So let's start writing the code. So let me remove this one. Give me a second. So yeah, what I'll do here, initially, let's initialize an empty array to store the result. Nothing but initially, we are setting this one to, we are setting the result variable to empty array, right? Next, what I'll do, let's initialize a variable to keep track of the product of elements to the left of the current element. That is nothing but I'll just take product and set this one to 1. As I have explained, initially we'll set the product to 1. Next, the first pass is, let's compute products of all elements to the left of each index. I'll just make use of the for loop. I'll just give let I equals 0, I less than length of the nums, and increment the I. Next, for the current index I, store the product of all the elements to its left in the result array. Initially, we'll be pushing 1. If you remember, we have pushed 1, and later we'll push the elements according to the formula, right? I'll just give result dot push of product. So the next step is, we are updating the product variable to include the current element. How can we do that? I'll just give product equals product into nums of I. So I showed this one during the first pass, what we have done. In the second pass, we'll set the product variable to 1, right? Just to compute the products of elements to the right. So for that one, I'll just set, we already have the product, we have already initialized the product to 1, right? So we don't need the variable. I'll just give product equals 1. So after this one, let's make use of the second pass. Here, we are computing the products of all the elements to the right of each index. In this case, what I'll do, I'll just give for, from the right we are doing, right? So I'll just give j equals the length of the nums. This one, yeah, length of the nums minus 1, j greater than or equal to 0. Finally, let's decrement the, let's multiply the current index value in the result array by the product of elements to its right. While solving that one, I said that we are going to make use of the formula, nothing but result equals result into product, right? In the every step, in every iteration, I showed you. This is nothing but result of j equals result of j into product, and we have to update the product variable as well, right? Why? To include the current element, we have to update the product variable. So for that one, let me give product equals product into nums of j. So finally, what we'll do, we'll return the result array containing the product of all elements except itself for each index. Every time we are gonna this one now ignore the element that we are considering and we'll multiply this one, right? So for the first iteration, we'll ignore this one and we have to get 4 into 3 into 2, nothing but 24. Same thing goes with the similar thing we'll be doing, and we'll be getting the output 24, 12, 8 and 6. So in this case, let's return the result, right? Nothing but this one. In the resulting array, I showed how we got the output 24, 12, 8 and 6, right? So let me format this one. Let me submit this. So we can see we have got the correct answer, and the time complexity, they have 1 second. They have asked us to solve with the time complexity of big of n, right? And we didn't make use of the division operation as well. The time complexity will be, the time complexity of this one is big O of n. Basically, why it is big O of n? We are making use of the function which makes 2 passes over the input array, each of which is big of n, nothing but overall time complexity will be big of n itself, right, in this case. And the space complexity is also big of n in this case. So why the space complexity is big of n? The result array res that we have considered here, this one, right, it requires big of n space to store the product for each element. For the each element, it requires big of n space to store the products. We are making use of the additional space as well, nothing but the product, which is big of 1. So it will not basically affect the overall space complexity. So the time complexity, overall time complexity would be big of n, and the space complexity would be big of n as well. So yeah, this is it. Thanks for watching, guys.